This is a demo of what working with architecture as code looks like in practice. We will start with a small example product requirements document for a CRMLite application. Over the next few minutes, we'll generate a clean architecture API, but that's actually the least interesting part of this demo. We've all seen AI generate complete applications from a single prompt. What I really want to demonstrate is iteration speed and truly keeping the spec the source of truth. I'm going to make several requirement changes and demonstrate how quickly we can evolve the application without manually chasing down those changes through dozens of files or dozens of markdown files. It isn't about generating software once. It's about making the 20th change as easy as the first. So let's jump in. This is our starting point. We want to get to the full built-out application, but all we have to begin with is this PRD. It's a very simple PRD. We just want a very light customer relationship manager with a few different functional requirements associated with it. Won't go into detail. So the very first step is we want to generate this architecture.yaml. So we have a skill for that. Architecture as code, analyze. I should point out there's going to be a lot of sections with a lot of AI running through it. I will fast forward just to keep the video length not too long, but I'll use this timer as a wall clock so you can see when I fast forward. So let's start that. Okay, the skill has completed, and there's two artifacts that were created from it. One is this analysis markdown file, where it goes through and gives an analysis of that particular PRD, the requirements mapping, any considerations, assumptions that it made. Normally you'd want to go through this in detail. For the sake of this demo, I'm just going to move on and look at the actual architecture.yaml via the plugin, and we can actually see that it extracted the different entities, company, opportunity, contact, based upon the requirements, built out a few enums, and this is normally where I would also go through and do a little more evaluation, check the relationships. But in this case, we're just going to assume that everything's good, and we're going to continue on. So we're essentially here now. We have generated this architecture.yaml file full of clean architecture entities and constructs from the PRD. Now we're going to go through the architecture as code engine to try to generate the actual running API from this definition. We follow the pattern similar to Terraform, where you do a init and apply depending upon if you have major changes or just small changes. So we're going to go through and do first an init. This will set up the infrastructure, the TOML file, all the dependencies. Now we'll run the apply. At this point, it's determined which sections of the API actually require an LLM, a lot of these custom methods, and it has spinning off individual agents in the background to work on each one. They will work in parallel to complete the iteration even faster. So now it's done. We're just under 10 minutes. And we actually have the source code in place for a running API. If I go to the API Explorer, I can actually start it up right here. And it's live. I can check out the Swagger docs for it here. And we can see the different entities, contact, opportunities, and their generated endpoints all in place. So now we are here. We've actually generated the first pass of the API based upon the spec and architecture.yaml based upon the PRD. Then we'll kick off generating the UI for this API. So this is a completely empty repository. And what's interesting is when you have an API, vibe coding actually is very powerful. So with a single prompt, I'm just going to tell Sonnet 5 here to build a React Tailwind UI based upon this definition of the running API. Give it light blue, green color, make any other design decisions yourself. So I'm going to kick that off and let it run in the background. You could hand this off to a different team. So while that's running, even though we have an API, it's kind of boring because there's no data in it. So we want to go back. We have another skill called seed. And what this will do is actually analyze the architecture and we'll build up some example records that include the relationship so we can navigate across this model meaningfully. So it's done. So it is now populated. It has some example data. So if we go back to the API Explorer, restart it, now we have some example data that we can kind of navigate this particular domain model. We can look at opportunities, the users associated with them, the companies associated with them, and navigate through, and even use this as a preliminary, go back to the business unit. Is this the kind of stuff you're thinking? So we are here at this point. We have fully generated an API. It's running. We have some sample data against it. We can interrogate it from the Explorer. We could hit it via curl, whatever tools you wanted to. In the background, we're building a UI against it. So now let's go into iteration 2. What happens when you start changing things? Things need to change. Requirements are discovered. So we're going to use the case of we're going to add a new attribute. We're going to add lead source as an attribute. As we're reviewing this with the business user, they realized, oh, we really need to know when there's an opportunity where it came from. Okay, so all we have to do is go back to architecture. We can edit it right here. And we just want to add in a new attribute. We'll take that as a string, save this down to the architecture.yaml, and that's it. All we have to do at this point is do another apply. Now, this apply will run faster because it's already applied everything else. It actually does the delta between the two and says what needs to change and only goes through the process of what needs to change. Those 5 or 6 subagents that were kicked off the first time do not need to be kicked off again because that code is not changing. So about 52 seconds later, the apply is done. If I go back into the API Explorer and restart it, we'll actually see we have a new column here for lead source. It's a part of the API. It's documented as part of the API. It's in place. It's live. So let's do another change, maybe a little bigger one. We want to add a reopen method. So if we go back to architecture.yaml, we could do the same approach. We could go through there and just modify it directly, but we don't have to go through this interface. A lot of times I find it easier to actually just express this stuff in natural language. So I'm just going to give a prompt here to Claude to say, please update the architecture to add a reopen method on opportunity that will set the stage to lead, but only if the current stage value is not closed one, in which case you'd raise an error. Make it externally visible via an endpoint. So you can start to manipulate this architecture with natural text, but your focus is here. You don't have to look at code, you're looking at the model, and how you want things to interact. So let's send that prompt off. A couple of questions as I look through the definition. So it went through, modified the architecture.yaml, realized there's the one new method, and it's kicking off the subagent now to actually implement that based upon the text that's in the definition for that method. Okay, so that process is now complete. If we go back to the API Explorer, we'll actually see we now have a reopen method, and if I select one, I can actually execute it, and it changes the stage back to lead with this response across the wire. So let's check back on the UI generation. It looks like it has completed here. If we open that up, here's actually the UI that it generated from that one prompt hitting against that backend database. And it's live. Now, one of the things we went through already is we're on our third iteration. And if you remember, this actually started working against the very first one. So a few changes have come along. But what's nice about this is I can actually just give it a very generic prompt. Oh, hey, the API changed underneath you. Go check the definition again and just update this UI accordingly. So I can kick that off, and within 2 to 3 minutes, it'll actually be updated with all those modifications that we made over the past couple of iterations. So here we are, just under 25 minutes in, and we are actually at this point. We have fully generated this entire stack. We have a running API. We have a front end that's talking to that API. It's updating right now for the latest iterations, and we can just keep iterating. So now, what I want to do is shift gears, and let's say we've done this another 20 times or so. So now we're on iteration 25. And this is starting to be ready for like a QA deployment where we can get more people on it, and we want to test out the back end scalability, throw a lot more data at it, harden the system. So the next thing we want to do is we've been running very dynamically off of just in-memory databases. This is a beautiful part about clean architecture. You really don't care. So what we want to do now is like, let's flip this to a real database. So let's go back to the architecture. And what we want to do is wire up the persistence. So we'll take SQL Server. Let's do local Docker, persist everything. Okay, so now since we need to do an AAC init because we have new dependencies, and we need to apply. Okay, so it built out an env docker example. This is just local Docker, so I can just give it any database name, and let's just give it a simple password and rename this to be the one to use. Now I can actually go to the API Explorer. We'll stop this one. And when I now have a new option, I can select run the API with the Docker backend. And you'll see it's actually starting up Docker in the backside. And now this whole API is running against SQL Server running in that Docker API. I can start to do performance testing. I can check how it scales if I put in thousands of opportunities and continue to harden the system. So that's it. That's a quick pass through working with architecture as code to quickly iterate on requirements and continue to put out a clean architecture API that you can quickly iterate on. We're on our 5th or 6th iteration in 30 minutes. And we have a working full stack API with a React front end and a clean architecture API on the back end.